So the question is the shortest path in undirected graph having a unit distance. So it is a medium level question of GFG practice. So the question is given as we are given an undirected graph of n vertex and edges, and we are given a source node, and we have to basically note the shortest distance between the source and each and every vertex of the graph. And if somehow that vertex is not reachable, then I have to just return -1 in that place. So now this is an example given where we are given edge list. So we have to make a graph out of it basically. So I have made the graph here, and let's discuss its algorithm. So basically what I'll do first, I will take our distance array. I will call it our distance array, which will eventually be our answer. Okay, so basically what our distance array tells. Basically distance array tells us that initially every node from the source node, the source vertex, is unreachable. So that's why I have marked it as infinity. And I have taken a queue data structure for a standard BFS traversal. Now the algorithm is pretty simple. What I'll do, I will first mark the distance of source node to be 0. As we know that from source node to source node, the distance is nothing but 0. So I have marked it here, the distance array, the distance of source node to be 0. And at the same time, I'll push that node to the queue. Okay, now what I'll do, I will start the standard BFS traversal from the node that is present in our queue. So I'll first take out this queue from here, and I'll put it here. So now what I do, I'll just traverse to its neighbors, because in the BFS traversal we traverse breadthwise. So this neighbors are 3 and 1. From the graph we can see its neighbors are 3 and 1. Okay, so what I'll do first, I'll go to neighbor 1, and the distance of what I'll do, I will check the current distance and the distance of the weight, basically add it and check whether it is less than the distance in our distance array or not. So let me write it. So the distance, the formula is basically distance of the current node plus 1, which is the 1 is the weight of each edge weight, is less than, I will be checking in if condition, if this is less than the distance of the adjacent node, basically a neighbor node. I can say if this condition will be true, then only I'll update the distance of adjacent node to be 1 plus distance of basically node. है ना? So here the question is, so 1, basically 1, so it is nothing but distance of node is currently 0. Here distance of node 0, 1 is plus 1 is less than adjacent node distance is infinity. So obviously 1 is less than infinity. So what I'll do, I'll just update the distance of 1 to be 1. And at the same time, I will push this node to our queue. Now I'll move to 3, which is the second adjacent node of 0, and its distance is also infinity, and the same condition will be followed. So I'll update this to 1 and push it to the queue. Now I'll take out 1. Okay, so basically I'll take out 1. Now its adjacent neighbors are 2 and 0. So 0 has already been processed and its distance is, so okay, let me calculate for 0 also, and further I will move here. So yes, so 1 adjacent node are 2 and 0. So first I will process, suppose 0, whose distance has already been marked. So let's take 0 initially. So the 0 distance of node, the distance of node 1 is 1 plus 1 is less than 0. Is this condition true? No, this condition is false. So now the distance of a node 2. So basically for 1 we are taking and its adjacent node is 2 also. So the distance of node 1 is 1 plus the distance of node 2, the edge weight of 1 is less than infinity. So 2 plus is less than infinity. So I'll update the distance of 2 to be 2 and I'll push it to the queue. Now I'll take out 3 from here. Basically, I'll take out 3. The node is 3. Its adjacent are 0 and 1. It has already been processed. Now I'll move to 4. So the distance of node 3 is 1. The edge weight is also 1. Is less than infinity. So 2 is less than infinity. So I'll update the distance of 4 to be 2 and I push it to the queue. Okay, so now our next node is basically in the queue is 2. So we'll take out 2. The adjacent node is 1 which is already been processed. And the second is 6. So I'll go to 6. So distance of basically node is 2 and this distance is 1. 2 plus 1 is less than infinity. So 3 less than infinity. Yeah. So I'll update the distance of 6 to be 3. Okay, now the next node comes out to be, I think it is, and I'll the same time I'll push it to the queue 6. Now I'll take out 4. Now distance of 4 is nothing but 2 and its adjacent node is 5. And the distance is 1 here basically. So what I'll do, I'll just 2 plus 1 is less than infinity, 3 less than infinity. Yeah, so 3 less than infinity, so I'll update it here as 3. Now I'll update and push 5 to the queue. Now I'll take out basically 6 from the queue. Yeah, 6 from the queue. Its adjacent node are 5, which is already been processed. Adjacent nodes are 7 and 8. Distance of 6 is nothing but 3 and edge weight is 1 here, 1 here. So 3 plus 1 is less than infinity. Yeah, absolutely. So I'll update it to the yeah 4 and also to 8 is also because it is also adjacent to 6 also to 4. Now 7 and 8 I'll push to the queue. Now I'll take out 5. I'll take out 5. I'll check 3. 3 is the distance till 5 plus 1. Adjacent node is 6. 3 plus 1. It is less than 4. So basically, distance of 6 is 3, not 4. Basically, distance of 3 is 6. 3, sorry. 3 plus 1, 4 less than 3. So this condition is false. We will do nothing and move forward to the next. And same for 7 and 8. This condition, because in this 4 is less than 4 will be the output and we will do nothing in this case and the queue will become, basically queue will become empty and our array is completely filled. So let's check this array whether it is true is not. So 0, 1 to 1, 2, 3, 3, 4, 4. So 0, 1 to 1, 2, 3, 3, 4, 4. So the answer is correct. Only we have to return this. Now there can be a case when some of the node are unreachable, which means basically a connected component. In that case, it will be left as infinity. So what we will do, we will again traverse the distance array, and if we find any of the distance to be infinity, we will update it with a -1 basically. So time complexity will be straightforward. Time complexity will be, I think, I guess, yeah. Since we this is standard BFS traversal, time complexity is OV plus 2E because these are undirected edges. Space complexity, we are using Q array, so OV basically the vertex plus OV the array distance array height. So basically OV is our final space complexity. So now let's code this solution. So basically for code we first we have to make the adjacency list. Yeah, then the queue and the array. Okay, so now let me declare first the adjacency list of size and basically it is the number of vertex. Now what I'll do, I'll just traverse all its edges, which is m, and now what I'll do, I'll just mark dot push back something, and basically I will do it two times because it is the undirected graph. So edges and I comma 0 to edges I comma 1, and opposite of this edges I 0 to, since it is the undirected graph standard adjacency list procedure, 0, yeah, and 1. So our graph is now made. Now what I do, what I have to do, I'll just make a distance vector, basically distance vector of size n with the value basically int max, which is infinity. Now what I'll do, first I will mark the distance of the source node to be 0 now. So distance of source node to be 0. Now I will make a queue int, yeah, and then I push q dot push source node basically into the queue. Now I'll start the standard BFS, that is while queue is not empty, I'll just take out the node q dot front, yeah, and then I'll just pop it q dot pop. Now I'll just move to its adjacent neighbors, yeah, adjacent of node actually. Now I'll just check this condition, basically if distance of node plus 1, which is the edge weight, is less than the distance of adjacent node. ठीक है ना? So distance of, sorry, if distance of node, yeah, plus 1 edge weight is less than distance of adjacent node, which is in this case is I, then what I'll do, I'll just mark the distance of the adjacent node to be distance of node plus 1 edge weight, and at the same time I'll push it to my queue. Okay, yeah, the code is complete. Yeah, now what I'll just do, I'll just again traverse as the question requires. I have to return -1 in case it is not reachable. So what I'll do, I'll just traverse my distance array and I'll check if at any distance I equal int max. Basically, if it is infinity, then I'll just mark that distance I to be -1 basically. Okay, now I think the code is complete and I'll just return the distance array. Okay, now let's check whether it has any error or not. It should have not have error. So basically let's try to submit the solution for this. Mm, I think yes, the